Okay, so we have to talk about quadratic equations. Remember, we have always been in the past talking about quadratic expressions or functions. So f of x would be equal to ax squared plus bx plus c, right? That would be a quadratic function. Now remember, f of x and y can be interchanged, so it could have been ax squared plus bx plus c as our function. Now we're going to talk about quadratic equations, and we can, by setting y equal to 0. Okay, so now we have, these were functions, but now we have an equation, not to be confused with this heading up here. That's why we want to box that off. 0 is equal to ax squared plus bx plus c. Now, of course, these are very related. If we find the solution to this equation, we'll find the x values, some x value, and oftentimes we'll find two x values when it's quadratic. But that's the same thing as finding the zeros of the function. So you're going to get directions that ask for find the zeros of this function, or you're going to get directions that say solve this equation. It's basically going to be the same thing. Zeros of the function, you'll just go up here and replace the f of x with a 0. That would make the function 0, and then you would find the x value, then made that true. Okay, so that's one way to say it. So we can say solutions to the equation, we can say zeros of the function. Another word for solutions could be, though, you could also say roots to the equation, okay? And that would mean the same thing as the solution to the equation where the function was equal to 0. So all those things, all those words, the roots, the solutions to the equations, and the zeros of the function all mean the same thing, okay? But you'll remember, I want to keep going back to this 0 of a function. If y and f of x are fairly interchangeable, then if we graph a quadratic like so, what's interesting here is when the function is 0, the y values are 0, right? And what is that if nothing but the x-intercept of the graph? So the 0 of the function is the same as the x-intercepts of the graph, okay, which is the same as the solutions to the equation f of x is equal to 0, which is the same as the roots of the equation. Alright, so lots of different ways to ask the same question. Okay, here's one of the most important things we're going to talk about, zero product property. Okay, and this is our method, one method for solving a quadratic equation. So say you had a product of two factors, a times b. So a is a factor, b is a factor. Together, when you multiply them, they are a product. That product is equal to 0, okay? If a is equal to 0 or b is equal to 0. Okay? So that is the zero product property right there. So if you have multiplication of two things equal 0, one of them has to equal 0. They both could equal 0. Okay? That would definitely end up with a zero product, but it's okay to have just one being 0 as well. So that's our zero product property, and how does that help us solve quadratics? You probably know. We're going to do that with factoring. So let's take an example. How about x squared minus 3x plus, what do you think about this? Oh, 2, yeah, that'll work. Let's keep it simple. Okay, so in this case, I'm going to start by factoring. Why? Because I don't have products yet. I can't use the zero product property because I have terms in this case. Remember, there are three terms. They are separated by addition or subtraction. So the idea is to get factors by factoring this expression. So how do you factor this? Of course, you're going to call it two binomials. It's going to have to be x and x. To make the 2 here, it's got to be 2 and 1 for a multiplication, and indeed these will add up to 3 if I make this minus and minus. Okay, so that's going to equal 0. Don't forget to maintain your equation. Don't be sloppy and stop writing the equal 0 because that's important. Okay. Then you're going to do your zero product property. So if together they're equal to 0, then separately, let's set them equal to 0. So now I have these two separate equations to solve. X is equal to 2 and x is equal to 1. And those are your two solutions to the equation. Okay, I want you to try one using the zero product property. First you'll need to factor, and maybe there's a little trick even before that. So make sure you pick that up, see what answer you get, and we'll check it. Okay, and I'm getting x equal negative 4, x equal negative 2. Remember, the little thing you needed to remember to do beforehand was to make sure you have a 0 on the right-hand side. You have to have your quadratic expression equal to 0, that's so important, before you can start factoring. So that's where we're at. Here's an example I like to show everybody because it's a very common error that everybody likes to make. So don't be one of those, and we want to factor this. And hopefully you remember that you're always going to do your common factors first. And these are only two terms, but they do have a common factor. They both have an x, okay, so take it out in the front. That leaves you an x minus 3 is equal to 0. Now, these are two factors, okay? Just like we had before, I just didn't put parentheses around this factor because I didn't need it, okay? But it's still a factor. This is your a factor. This parentheses over here is your b factor. So I'm going to make a t-chart. Either x is equal to 0 or x minus 3 is equal to 0. Okay, so this one's done. See how nice and easy that one is? And then this one, of course, x is equal to 3. Alright, so the thing that happens, a lot of people, they want to lose that x, but you can't, okay? You need to have that solution x equals 0. Now, sometimes we're going to solve equations, quadratic equations by graphing. So say I say f of x is equal to, and I could just say, it doesn't matter, blah, 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 okay? But the graph is given below, okay? So I'll give you the graph of it, okay? So here it is, here's the graph. You come through here, and it's got a nice little parabola shape, like so. 1, 2, 3, okay? And you look at this and say, okay, what if she asked the question, find the zeros of the equation? Okay, so what am I asking for? I'm asking when is the function equal to 0? What is the x values? So you look at this and you say, well, right here, I have the function equal to 0 because the y value is equal to 0. And over here, I have the function is equal to 0. So those are the zeros of the function. X equals 1 and x equals 4 are the zeros of the function, and you can do that just by reading the graph. So that's a really nice, easy way to do it. Okay, another way you can do this is if somebody provides you with a table, or if you have a nice calculator that'll do a table, or if you're just going to plug and chug and fill in a table. But let's say you have this equation, and I want to solve it, okay, for its roots, okay, solve the equation, find the solutions. Then I could fill out my table, but I'm going to fill the table with y is equal to this same expression, okay? That's a square, 32x plus 12. And then what happens, I'll fill it in. Okay, I went to a lot of trouble, filled in this table. I can solve this now by simply looking at the table. Obviously, y is 0, okay? So y is 0. That's what we're looking for to solve that equation. So x equal negative 6 is the solution when the y value is equal to 0. But here's the trick. Where's the other 0? You have to think about this. When you have a graph, okay, and let's see, the other one's going to be like here. Okay, sorry for all the noise. So here's 1, 0. And then all the y values are negative, right? Negative, 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 negative y values. And then all of a sudden, now all the y values are positive, right? All those y values over there are positive. So when it switches from y being negative to y being positive, somewhere in between there, y has to equal 0. And that's the trick, okay? So right here, between y is negative and y is positive, I know y has to equal 0. So find a place where y is negative and then it changes to y is positive. Somewhere in there is going to be a 0. So y equals 0 is somewhere between those two places. So somewhere between these two places, same place on your chart, is your value of x. So we know x lies the second root, okay? X lies between negative 1 and 0, okay? So you can make an estimate. This is an estimate, okay? And one of the things you could do then is you could say x is approximately minus 0.5, and that would work. You could either say it's between these two numbers, or you can give me an approximation that lies between those two numbers, okay? So that's a nice way to make an estimate based on just a few values.